So welcome to JEE Advanced 2026 Paper 2 Mathematics discussion. So let's go to the first question. So let vectors a bar and b bar be such that let p comma q comma r be points with position vectors a bar, b bar and a bar plus b bar with respect to origin. If mod of a bar plus b bar is equal to root 21, mod of a bar minus b bar is equal to 3. So this is the first piece of important information in this question. Keep this in mind. And if a bar and a bar minus b bar are perpendicular to each other, this is a second piece of information which is useful in this question. What is the area of triangle OPR? So let's represent this information in the form of a diagram. So with respect to origin, a bar and b bar are two vectors. So let us say that this vector is a bar. Let us say that this vector is b bar. So PQR are points with position vector a bar, b bar and a bar plus b bar. That means this point is P. P is the point with position vector a bar. Q is the point. So this point is Q. And the point R corresponds to the position vector a bar plus b bar. So we know that by using parallelogram law of addition. So P bar plus Q bar. So this vector represents a bar plus b bar. So the point with position vector a bar plus b bar is R. So mod of a bar plus b bar is equal to root 21. That's first piece of information. Mod of a bar plus b bar, you can write whole square is equal to 21. Mod of a bar minus b bar whole square is equal to 9. And a bar minus b bar are perpendicular to each other. A bar dot a bar minus b bar is equal to 0. These are the three numerical informations given in the question. Then they're asking you area of triangle OPR. This area is being asked. So clearly this is half the area of the parallelogram. We know that the area of the parallelogram is a bar cross b bar modulus of this. So area of triangle OPR is nothing but half of mod of a bar cross b bar. So if you can just find mod of a bar cross b bar, we are done. So let us see if using these informations we can get the value of mod of a bar plus a bar cross b bar. So a square plus b square plus 2 times a bar dot b bar is equal to 21. So a square plus b square minus 2 times a bar dot b bar is equal to 9. And a bar dot a bar a square minus a bar dot b bar is equal to 0, which implies a bar dot b bar is equal to magnitude of a whole square. So now using these two informations, we'll add them first and then subtract them. We'll see what comes out. So 2 times a square plus b square is equal to 30, which implies a square plus b square is equal to 15. And if you subtract them, so you get 4 times a bar dot b bar is equal to 12, 21 minus 9. So a bar dot b bar is equal to 3. So if a bar dot b bar is equal to 3, which will imply a square is equal to 3. And if you put a square is equal to 3 in this equation, you'll get b square is equal to 12. Now you want mod of a cross b. So we can use this formula which says that mod of a cross b whole square plus mod of a bar dot b bar whole square is equal to a square b square. So which implies mod of a bar cross b bar whole square is equal to a square into b square is clearly 36 minus a dot b whole square is 9, which is equal to 27. So mod of a cross b is 3 root 3. So you get 3 root 3 by 2 to be the answer. So option C is the right answer for this question. So hope you have understood the working of this question. So the main idea that is involved in this question is equation manipulation, and understanding that this area is half the area of the parallelogram, and which can be found out by using the formula for area of parallelogram. So now let's go to the next question. So this is a question on coordinate geometry, parabola. So let t be the tangent to the parabola y square is equal to 16x at the point 64, 32. Let L be the tangent to the same parabola at another point x1, y1 on the parabola. Let if L and T are perpendicular to each other, the distance between point x1, y1 and the focus of the parabola. So while reading itself, if you draw the diagram parallelly, it will be easy to understand. So let us draw the parabola y square is equal to 16x. So let us say that this is y square is equal to 16x. So on this you have a point according to them which is 64, 32. Now t be the tangent at this point. At this point you have drawn the tangent, right? Let L be the tangent to the same parabola at another point x1, y1 on the parabola. So where is x1, y1? We don't know. For that, we'll go to the third sentence. If L and T are perpendicular to each other, that means this is tangent T. Now you have drawn a perpendicular tangent to this. So we know the concept of perpendicular tangents in a parabola, right? So the perpendicular tangents to the parabola meet on the directrix. That's the first condition. And the points of contact, if you join together, they'll form a focal chord. So if you represent the first point as A, and if you represent the second point as B, which is x1, y1. So because this angle, the angle between the tangents is 90 degrees, the endpoints A and B form a focal chord. That's the concept. So that means focus is somewhere on this. Because this is y square is equal to 16x. If you compare 16 with 4a, the focus is 4, 0. So now they are asking you what is the distance between the focus and the point x1. They are asking you SB. So we know that 1 by SA plus 1 by SB is equal to 1 by A, right? This is the formula that connects the focal segments. So SB can be easily found out. So SA is equal to root of 64 minus 4, 60 square plus 32 square. So if you take a 4 square outside, this is like 4 square into 15 square plus 4 square into 8 square, which is equal to 4 can be taken out, root of 225 plus 64, 289, which is equal to 4 into 17. So 1 by SB is equal to 1 by A is 4 minus 1 by 4 times 17, which is equal to 1 by 4 times 1 minus 1 by 17 is 16 by 17. So this implies SB is equal to 17 by 4. So a very easy question. So single concept question. If you just know this formula, 1 by SA plus 1 by SB is equal to 1 by A, the question is very straightforward. And one more concept that needs to be understood for this question is the point of intersection, the points of contact of the perpendicular tangents form a focal chord. So I hope this is clear. So let's go to the next question. So the third question is from differential equations. You're asked to solve this differential equation. Dy by dx is equal to e power 5x y cube plus y cube by e power x plus e power x y power 4. Y of 0 is given. Y of ln 2 is being asked. So this question was also given very easily. There's nothing much in this question. Just variables are separable in this. So if you take y cube times 1 plus e power 5x divided by e power x times 1 plus y power 4, right? So variables can be separated very easily, which implies dy into 1 plus y power 4 by y cube is equal to e power 5x plus 1 by e power x into dx. So if you integrate it on both sides, very easy to integrate. 1 by y cube, y power minus 3, y power minus 2 by minus 2, plus y power 4 by y cube is y's integration is y square by 2 is equal to e power 5x by e power x is e power 4x. So e power 4x by 4 plus e power minus x integration is e power minus x by minus 1, right? So this plus will become minus plus the integration constant. So now to find the integration constant, this information is given. Y of 0 is equal to 1 by root 2. We'll put x is equal to 0 and y is equal to 1 by root 2. So we have to put x equal to 0 and y is equal to 1 by root 2. So minus of 1 by root 2 whole square is 1 by 2. Y power minus 2 is 2 by 2 plus 1 by 2 into 2 is equal to x is 0. So 1 by 4 minus 1 plus c. So which implies minus 1 plus 1 by 4 minus 3 by 4 is equal to minus 3 by 4 plus c, which implies c is equal to 0. So the integration constant is 0. So what is the equation? So y square minus 1 by y square, I'll send 2 onto that side, is equal to 2 times e power 4x minus by 4 minus e power minus x. So let's find y of ln 2. So x is equal to ln 2, y is equal to how much? That's the question. So if you put y is equal to ln 2, so this 4 goes up, it is e power ln 16, which is equal to 16 by 4 is 4. So y square minus 1 by y square is equal to 2 times 4 minus, so here also in the place of x, if you put ln 2, this will be ln 1 by 2, so minus 1 by 2. So 4 8 minus 1 7 by 2, so this will become 7. So y power 4 minus 7y square minus 1 is equal to 0. Y square is equal to 7 plus or minus root of 53 by 2, which implies y is equal to square root of 7 plus root 53 by 2. So option B is the correct answer. So very straightforward, variable separable differential equation based question. So no traps. So direct apply the process, you're going to get the answer. So let's go to the next question. This is also a very simple question on definite integration. So integration 0 to 2 3 power x plus 3 exponential type question. So let us take 3 power x as t. So this integral becomes, so if you differentiate it, 3 power x ln 3 dx is equal to dt. So when x is equal to 0, 3 power x is 1. When x is equal to 2, 3 power x is 9. So integration 0 to 9 dx is dt by ln 3 into 3 power x is nothing but t into 3 power x is t plus 3, which is equal to 1 by ln 3 times integration 1 to 9 1 by t plus 3 into t dt. So it's a very simple splitting type question. So you can multiply and divide with 3. This can be written as 3 by 3. Now this 3 can be written as a t plus 3 minus 1 minus t, right? So that is equal to 1 by 3 ln 3 integration 1 to 9 1 by t minus 1 by t plus 3 dt, which is equal to 1 by 3 ln 3 into ln t minus ln t plus 3 going from 1 to 9, which is equal to 1 by 3 ln 3 ln 9 minus ln 1 minus ln 12 plus ln 4. So this is gone. So 1 by 3 ln 3 into ln 9 into 4 by 12. So 9 3 3s are 3 4s are. So ln 3 is getting cancelled. So the answer is 1 by 3. So hope you are getting the solution. It's a very straightforward process based question, no complicated theory points in this. So next, so this is about the single correct option type questions. So all straight objective type questions. There are no multi concept type questions in this section. So now let's go to the second section, which is multi correct type. So let R be the set of real numbers, and consider the polynomial f of x is equal to x square d by d 10 by dx power 10 of x square minus 1 whole power 10. So here f of x is the 10th derivative of x square minus 1 whole power 10, the 10th derivative. Okay, it's not very straightforward, but try to understand this. So x square minus 1 whole power 10, it's not very easy to do derivative 10 times. Okay, now which of the following options are correct? So you have 4 options. They're asking you the coefficient of x power 8, f of 1 plus f of minus 1, degree of the polynomial f of x, and the constant term of f of x is. So these are the 4 questions that are being asked. So let us try to see how we can go forward here. So d10 by dx power 10 of x square minus 1 whole power 10. So first, so clearly x square minus 1 whole power 10 is a 20th degree polynomial, right? So I think that is clear for you. From binomial expansion, if you expand it, you're going to get a 20th degree polynomial. And now if you differentiate it 10 times, obviously you're going to get a 10th degree polynomial. So the option C is directly right. Now once we have observed C, A, B, C are about finding different coefficients, right? So now let us uh, try to analyze this. So first way of analysis is x square minus 1 whole power 10 is equal to 10 c naught into x power 20, that is x square whole power 10, minus 10 c1 into x power 18 plus 10 c2 into x power 16 minus plus so on 10 c10 into minus 1 whole power 10, which is 1. So you have, when you expand x square minus 1 whole power 10, you have x power 20 coefficient, x power 18, x power 16, so on. Now when you differentiate it once, this term is going to go off. So it becomes a 19th degree polynomial. So now each of these differentiation will slowly reduce the power of each term. So now I want x power 8 coefficient, right? And the constant term. So obviously you'll have, I think, so let me write the relevant terms here. So x power, I think 18 term on differentiating 10 times is going to become the x power 10 term, right? X power 8 term. So if you want x power 8 coefficient, you have to see what is going to happen to x power 18 term. So I'll write this minus 10c3 into x power 14, so on. So this second term is the important term for option A. Next, after that, you are asked to find f of 1 plus f of minus 1. Let us do that afterwards. And constant term. So here, as you go forward, x power 10 term will be there, minus 10c3, so plus 10c4 into x power 12 minus 10c5 into x power 10. So this term is going to become the constant term after 10 differentiations. So let us do 10 differentiations here. If you take the first term, 10 x power 18 term, so minus 10c1 into, so when you do the differentiation first time, 18 into x power 17, so 18 into 17 into 16, so on, you're going to get 10 terms, right? So 18p10. So starting from 18, you're going to get 10 terms, which is nothing but 18p10. So which is equal to minus 10 into 18 factorial by 18 minus 10 factorial is 8 factorial. So I think a coefficient of x power 8 is that. Now, what is the coefficient? What is the constant term? Constant term is going to come when you differentiate this, right? So minus 10c 5 times. So x power 10, if you keep on differentiating, so you're going to get 10 factorial, right? That's a constant term that you're going to get. So is it correct? Minus 10 factorial by 5 factorial into 5 factorial into 10 factorial. So I think this is wrong because 10 factorial and 5 factorial doesn't cancel each other, right? So it's not minus 10 factorial by 5 factorial. So this is wrong. Now, what is f of 1 plus f of minus 1? So usually f of 1 plus f of minus 1 is nothing but the 2 times the sum of even powers of x, right? So if you just try to take this forward, what I have observed is doing this kind of process is going to give you some complications in finding f of 1 plus f of minus 1. So what I'll do is I'll follow a different process to find f of 1 plus f of minus 1. So let me just try to use something called Leibniz theorem. Leibniz theorem of continuous differentiation. So what this says is, if you have two functions uv, the nth derivative of uv is nothing but nc naught, the nth derivative of u into v, plus nc1, n minus 1th derivative of u into first derivative of v, plus nc2, n minus 2th derivative of u and the second derivative of v, plus so on, plus ncn. ఒకసారి కట్ చేస్తారా మళ్ళీ. So to find f of 1 plus f of minus 1, let us use a different process. So I'm going to use something called Leibniz theorem. So Leibniz theorem for continuous differentiation. What this theorem says is uv, the nth derivative of uv is n times nc naught times the nth derivative of u into v, plus nc1, the n minus 1th derivative of u into the first derivative of v, plus nc2, the n minus 2th derivative of u into the second derivative of v, so on up to ncn, the direct u function into the nth derivative of v. So here we are trying to differentiate x square minus 1 whole power 10. I want the 10th derivative of this. So this can be written as x minus 1 whole power 10 into x plus 1 whole power 10. So x square minus 1 whole power 10 can be written as x minus 1 whole power 10 into x plus 1 whole power 10 is the 10th derivative. I want the 10th derivative. So this 10 is not power, it represents the 10th derivative. Okay. So this can be written as 10c naught into the 10th derivative of x minus 1 power n will be 10 factorial, right? So it just first derivative will be 10 times x minus 1 power n, 10 into 9 into x minus 1 power 8, so on. If you do 10 derivatives, it will become 10 factorial into x plus 1 whole power 10 plus 10c1 into the ninth derivative will be 10p9. You'll have 9 numbers starting from 10 into 1 x minus 1 will be remaining into the first derivative of x plus 1 whole power 10 is 10 times x plus 1 whole power 9 plus 10c 2 times, you have to differentiate x minus 1 power 10 8 times. So 10p8 into x minus 1 whole square into 10 times 9 times x plus 1 whole power 8. So if you are trying to see what I am going to do now after as I go forward, can you see that this is my f of x? So when you put x is equal to 1, okay, all the terms except the first term are going to become 0. And when you put x is equal to minus 1, all the terms except the last term are going to become 0. So what is the last term? So in every term in the middle, you'll have at least 1x plus 1 and 1x minus 1. Okay, so the last one is plus 10c 10 into the first function will be as it is this time, x minus 1 whole power 10 into the 10th derivative of x plus 1 power 10 is 10 factorial. So now when you take f of 1, so except the first term, all the terms are going to become 0. So 10 factorial into 2 power 10, that is f of 1. F of minus 1, for f of minus 1, all the terms except the last term will be gone. So all the first 10 terms will be 0. The 11th term will be, if you put x equal to minus 1. So this is also 10 factorial times 2 power 10. So f of 1 plus f of minus 1 will be 2 times 10 factorial into 2 power 10, that is 2 power 11 into 10 factorial. So if you go back, what they are giving is the value of f of 1 plus f of minus 1 is 2 power 11 into 10 factorial, which I think is correct. So we got A, B, C as the answers to this. So now let's go to the next question. This is a question on Diophantine equations. So A, B, C are positive integers in arithmetic progression such that ax square plus bx plus c equal to 0 has only integer solutions. Then which of the following is true? So what are the informations given? A, B, C are integers. That's the first information, positive integers. And they are in AP, 2b is equal to a plus c is one condition connecting A, B, C. And ax square plus bx plus c equal to 0 has only integer solutions. So I think we can write ax square plus bx plus c is equal to a times x minus alpha into x minus beta. This is one way in which we can go forward. We can start solving. Otherwise, we can go for sum of the roots and product of the roots. So alpha plus beta is equal to minus b by a, and alpha beta is equal to c by a, right? So which implies a times alpha plus beta is equal to minus b, and a times alpha beta is equal to c. And what is the connection between b and c? 2b minus c is equal to a, right? 2b minus c is equal to a. So I'll multiply this with minus 2, and I'll multiply this with 1 minus 1 and add them, right? So if you add this, so 2b minus c is equal to 2a times alpha plus beta minus a alpha beta. So this implies a times 2 alpha plus 2 beta minus alpha beta is equal to 2b minus c is turning out to be a, right? So this a and this a gets cancelled. So you get 2 alpha plus 2 beta minus alpha beta is equal to 1. So whenever we have Diophantine equations type of question, we usually try to write the expression as something into something is equal to some integer, and we try to take it forward from there. So this implies, I think you have alpha beta minus 2 alpha minus 2 beta is equal to minus 1. I'll add a 4 on both sides, which implies alpha into beta minus 2 times beta minus 2 is equal to 3, which implies alpha minus 2 into beta minus 2 is equal to 3. Now alpha and beta are integers, so alpha minus 2, beta minus 2 is also an integer. So the product of two integers is turning out to be 3. So there are not many ways of doing this. So 3 can be written as product of two integers in only two ways, either it's 3 into 1 or minus 3 into minus 1. So if you take the different cases, the first case becomes alpha is equal to 5 and beta is equal to 3. So if you equate this with this and this with this, beta minus 2 is 1, so beta is 3, alpha minus 2 is 3, alpha is equal to 5. Or second, you have alpha is equal to minus 1 and beta is equal to minus 1 plus 2 is plus 1. But if you have alpha is equal to 1 and beta is equal to minus 1, now you can see that alpha plus beta is minus b by a, right? So b is becoming 0. But according to the question, a, b, c are positive integers. So this case can be discarded. So alpha is equal to 5 and beta is equal to 3. So the equation is a times x minus 3 into x minus 5, which is equal to a times x square minus 8x plus 15. So a, b, c are like a, 8a and 15a. So alpha is equal to 5 and beta is equal to 3, right? I think alpha minus 2 beta, so on. Okay, so alpha, beta, gamma, a, b, c should be like a, 8a and 15a. So if you take c minus b, which is 7a, is a integral multiple of a, which is correct, right? And both the roots of ax square plus bx plus c are odd integers, that's also correct. If c is equal to 15, that means a is equal to 1, ab is equal to 8, that is also correct. And if b is equal to 8, which means if b is equal to 8, that means 8a is equal to 8. So a is equal to 1. X equal to 3 is a root of ax square plus bx plus c. So I think what are the roots anyway here? Alpha is equal to 5 and beta is equal to 3. Did I get it wrong somewhere? Let me just check. Uh, so 2 alpha plus this is equal to 1. So if b is equal to 8, then x is equal to 3 is the root of the solution. If b is equal to 8. So I think I have got it wrong somewhere. You get the roots as alpha equal to minus 5 and beta is equal to minus 3. సార్ ఒకసారి కట్ చేస్తారా ఇది చిన్నది తేడా వచ్చింది స్టాప్ చేసేయండి ఒకసారి. So now in this question, it's given that a, b, c are positive integers in arithmetic progression such that the equation ax square plus bx plus c equal to 0 has only integral solutions, integer solutions. Then which of the following is correct? So what are the informations that are given in this question? A, B, C are positive integers is one piece of information. They are in arithmetic progression. And the roots of ax square plus bx plus c equal to 0 are integers. These are the three pieces of information that's given. So they're asking you about the coefficient. C minus b is a multiple of a. Both roots of ax square plus bx plus c are odd integers, so on. So let us try to write the corresponding equations. 2b is equal to a plus c. This is one equation. A, B, C are in AP. Next, ax square plus bx plus c equal to 0. Assume that the roots are alpha comma beta. These are positive integers. right? So let us try to go for alpha plus beta is equal to minus b by a, alpha beta is equal to c by a, right? So from this we can write b is equal to minus a times alpha plus beta, and c is equal to a times alpha beta. Now what is the connection between a, b, c? So you can say that a is equal to 2b minus c, right? So I am going to multiply this equation with 2 and subtract. So 2b minus c is equal to minus 2a times alpha plus beta minus a alpha beta. So 2b minus c is equal to this. So this side is a, right? This side is a. So this a are getting cancelled, which implies 1 is equal to minus 2 alpha minus 2 beta minus alpha beta. So which implies if you take everything onto one side, alpha beta plus 2 alpha plus 2 beta plus 1 is equal to 0. So now we'll try to express this side as something into something in terms of a product of two numbers. So for that I'll add a 3 on both sides. So this 1 plus 3 becomes 4. Alpha beta plus 2 alpha plus 2 beta plus 4 can be written as alpha plus 2 into beta plus 2 is equal to 3. So because alpha and beta are integers, alpha plus 2 and beta plus 2 are also integers. So 3 is being written as product of two integers. So this cannot be done in many ways. So this is either 3 into 1 or minus 3 into minus 1, right? So in the first case, alpha is equal to minus 1, beta is equal to minus 1. So both alpha and beta are minus 1, minus 1. In the second case, alpha is equal to minus 5 and beta is equal to minus 3. So the roots can be both minus 1 or minus 3 and minus 5. So if you just try to write the equation correspond to this, so the corresponding quadratic equation for this is x square plus 2x is like x minus 1 whole square, right? X square minus 2x. So the roots are minus 1 and minus 1. X square plus 2x plus 1 is equal to 0. So here the roots are minus 1 comma minus 1, right? They have this equation has all integral solutions, which is good. And if you take the next one, it's like x square plus 8x plus 15 is equal to 0. So anything, so a times this, a times this. So the one of the possible answers is a x square plus 2ax plus a equal to 0. The coefficients, you can see that the coefficients are not ABC are positive integers in arithmetic progression, but the coefficients are not in AP in this case. So we'll discard it, right? So alpha plus 2 is equal to 3. So alpha is equal to plus 1, sorry. So x square minus 1 is equal to 0. So you have 1x square a times x square minus 1 is equal to 0, which implies b is equal to 0 in this case, which is not valid. So let's go to the next case. The coefficients are a, 8a and 15a. So these are the three numbers which are in AP. So c minus b, which is 7a, which is always a multiple of a, which is correct. So both roots of ax square plus bx plus c are odd integers. So the roots are turning out to be minus 5 and minus 3, which is correct. Okay. And if c is equal to 15, AB is equal to 8, which is also correct. If c is equal to 15, that means a is equal to 1. So 8a square is 8, which is correct. And if b is equal to 8, if b is equal to 8, 3 x equal to 3 is a root of ax square plus bx plus c, which is wrong because x equal to minus 3 is a root. The roots are fixed. So minus 5 and minus 3 are the roots. So x equal to 3 is not a root. So a, b, c are correct for this question. So next, let us go to the next one. So this is a 3D based question. Let L be a straight line passing through PQ. So there are 2 points P1, 2, -1 and Q2, 3, 1. So S be the foot of the perpendicular of R 4, -1, 5. From here you have drawn a perpendicular. S is the foot of the perpendicular. Another line L passing through R intersects L at a point T such that PS is to ST is 1:2. So PS is to ST is 1:2. So this is the line that they are talking about. So a line through R is cutting the line L at a point T such that PS, this is to this, if this is x, this total is 2x. Which of the following statements are correct? So they are asking you the orthocenter of triangle PRT. Okay, the orthocenter, and they are asking you about the area of triangle PRT. So area of the triangle PRT is quite simple. For this, we'll find the foot of the perpendicular. So what are the DRs of this line? The DRs of this line is 2 minus 1, 3 minus 2, 1 plus 1, 2, right? So if you subtract the coordinates, you're going to get the DRs of the line. So 1, 1 and 2. So any general point on this line, I can assume S as a general point. So 1 plus lambda, 2 plus lambda, minus 1 plus 2 lambda. So that's a general point on this line. Now S should be such that this perpendicularity condition is to be valid. That means dot product of these DRs. So DRs of PS, DRs of RS is equal to, so this point minus this point. So which is lambda minus 3. So lambda plus 2 plus 1 lambda plus 3. So 2 lambda minus 6. So those are the DRs of RS, right? So the DRs of RS should be such that the dot product of these DRs and the DRs of the line L has to be equal to 0. So the dot product of these two DRs is equal to 0. So lambda minus 3 plus lambda plus 3 plus 4 lambda minus 12 is equal to 0. So which implies 6 lambda is equal to 12, lambda is equal to 2. So once lambda is equal to 2, we got the coordinates of S. So the coordinates of S are, if you put lambda is equal to 2 here, 3, 4, 3. So we got the coordinates of S. That's the first success that we have. So once we have this, instead of finding P, I'll just try to find the area of this triangle. So if the area of this triangle is delta, we know that because the bases are in the ratio 1:2, the area of this triangle has to be equal to 2 delta. So once we know delta, the total area is 3 delta. So I'll find the area of triangle PRS. So how do I find it? So we'll find this vector. What is the vector PR? Area of the triangle is half of side 1 cross side 2. So the vector is 4 minus 1, 3, minus 1 minus 2 minus 3, 5 plus 1, 6. And the vector PS is, you have this as S. So if you subtract, you'll have 2, 2, 4. So those are the components of vector PS. So delta is equal to half of IJK 3 minus 3, 6, 2, 2, 4. So I'm going for the cross product. So you have half of, so if you want, you can take a 3 outside and a 2 outside from this row, and from this you'll be left with IJK 1 minus 1, 2, 1, 1, 2. So 3 times the components are, I component is minus 2, minus 2, minus 4, minus of 2 minus 2, 0, 2. So the modulus of this is 3 root 20. So which is equal to 6 root 5. So 6 root 5 is the area of this triangle, but they're asking you the area of triangle PRT, which is 3 times this. So the answer is 18 root 5. So that's the answer. Next, you are going to go for the orthocenter. So there is no very simple way to find the orthocenter. So, but we know that orthocenter has to lie on this line, right? Orthocenter has to lie on one of the altitude. We know that RS is an altitude. So if you just we can go for verification method, that will be easy for this. So S coordinates are 3, 4, 3. So we'll go for the DRs of RS. The DRs of RS are nothing but, so if you subtract one from the other, minus 1, 5 and minus 2. So if you go for the actual calculation of DRs using this point and this point, if you take option B, you'll find that the DRs will not be proportional to these minus 1, 5, minus 2. Only the DRs corresponding to this point are proportional to this new DRs minus 1, 5, minus 2. So from that you can verify the option A. So option verification would be easy. So once you get this point, you also, for better to confirm your answer, you find the DRs of this line and then check whether the DRs are perpendicular to this line RT. So for that, you will also have to find the point T and go forward. So it's a lengthy question according to me, but you have to do it carefully, you'll get the answer. So let's go for the next question. So f of x is a real valued function defined in 0 to infinity. Y of 1 is equal to 0. Dy by dx is this. Which of the following is correct? So this is also a differential equation question. So direct dy by dx, if you take x onto the other side, is equal to y by x minus x square. So dy by dx minus y by x is equal to minus x square, right? So this is a linear differential equation. So what is the integration factor? E power integration minus 1 by x dx. So e power minus ln x, so which is equal to 1 by x. So what is the answer? What is the solution to this? So y times integration factor is equal to integration of q of x times integration factor dx. So y by x is equal to minus x square by 2 plus c. So to find this c, you are given y of 1 is equal to 0. That means when x is equal to 1, y is 0. So if you put 0 comma 1, sorry, you put 1 comma 0, which implies 0 is equal to minus 1 by 2 plus c. So c is equal to 1 by 2. So which implies y by x is equal to minus x square by 2 plus 1 by 2. So which is plus 1 whole divided by 2. So which implies y is equal to x by 2 times minus x square plus 1. So y is a cubic function. So it's a very easy to analyze this. F has local minima, local maxima. F is increasing in interval 1 to 2, so on. So y is equal to minus x cube plus x whole divided by 2. So dy by dx is equal to minus 3x square plus 1 equal to 0, implies x is equal to plus or minus 1 by root 3. So you have turning points at plus or minus 1 by root 3 if you consider the graph. So the leading coefficient is negative, so the graph would be like this. So the starting, the higher number will be maxima, will have a minima at the lower number. So at 1 by root 3 it has to be maximum, local maxima. At minus 1 by root 3 it has to be local minima. So this will be 1 by root 3, this will be minus 1 by root 3. So x is equal to 1 by root 3, f has local maxima. That's the first one. So the function f is increasing in the interval 1 to 2. So can I conclude that between 1 and 2, 1 by root 3 will be less than 1, 1 will be somewhere here, 2 will be somewhere here. The function is actually decreasing between 1 and 2, it's not increasing. So this is wrong, this is wrong. And g of x is equal to this, the number of elements f of x is equal to g of x in 0 to infinity is 2. So you just have to solve it. So minus x cube plus x by 2 is equal to 4x cube minus 5x square plus 3x by 2. So you just are going to get the cubic. X equal to 0 is one of the solution, but I want it in open 0 to infinity. So you cancel the x, get the corresponding quadratic and find the solutions. So you have to see how many positive solutions are there and how many negative solutions are there. So if you solve the quadratic, you're going to get the answer. So you're going to get both of the roots of that quadratic as positive. So D is also the correct answer. So let's go to the next question, ninth question. So this is the last question in MCQs. So here S and T are given. ST is ABCD, it seems. H is x plus IY, where y greater than 0. So you're asked to find some of these. So first let us find ST. ST is equal to 0 minus 110 into 1101. So if you multiply this, you're going to get 0, minus 1, 1 and 1. This is ST. Okay, so you want ST square. So ST is A, B, C, D. So this will imply A is equal to 0, B is equal to minus 1, C is equal to D is equal to 1. So you got all the values. So B plus IA by D plus IC. B is minus 1 plus 0 by 1 plus I is equal to I, which is wrong, right? Minus 1 by 1 plus I is not equal to I. So option A is wrong. So if omega is minus 1 plus I root 3 by 2, which is the complex cube root of unity, A omega plus B 0 minus 1 by 1 plus omega is equal to omega, which is correct, I think. Minus 1 by 1 plus omega is minus omega square. So 1 by omega square is omega. So LHS is equal to RHS. So B is correct. Next, let's go for D option. If Z belongs to H, what is H? X plus IY, where X and Y are any numbers, but Y is greater than 0. That means the imaginary part of the complex number is greater than 0, then it belongs to H. So if Z is a complex number with positive imaginary part, will AZ plus B by CZ plus D also have a positive imaginary part? So let Z is equal to X plus IY, where y is greater than 0. So Az plus b is a is 0, right? So minus 1 by z plus 1, which is equal to minus 1 by x plus 1 plus iy, right? If you put z is equal to x plus iy. So if you do conjugate multiplication, so this will become, the denominator will be x square plus y square, x plus 1 whole square plus y square. The numerator will be minus of x plus 1 plus iy. So the imaginary part of this is y divided by x plus 1 whole square plus y square. So if y is greater than 0, obviously this is also greater than 0, which implies if z belongs to h, this also belongs to h. So D is also correct. So next they are asking you if st square is equal to st power m, m is an integral multiple of 8. Let us see this. So what is st square? So if this is st, let us call the st as p. So let us try to write the characteristic equation for p. So p square minus of trace of p is what? 1. 1 into p plus det of p, 1, 0 minus of minus 1 plus 1 plus I is equal to 0. So what is the characteristic equation of a 2 by 2 matrix? P square minus trace of p into p plus det of p into I is equal to 0. So from this, p square is turning out to be p minus I. That is st square is turning out to be st minus I. So let's go for p power 4. P power 4 is equal to p minus I whole square, which is equal to p square minus 2I plus minus 2p plus I. Again, p square is p minus I, right? So this plus I and minus I is getting cancelled. You get minus p. So p power 4 is equal to minus p. And as you can see, p is a non-singular matrix, that is not equal to 0. So if you multiply with P inverse, you're getting P cube is equal to minus I. P cube is equal to minus I, which implies P power 6 is equal to I. So P power 6 is equal to I, which implies ST power 6 is equal to I, right? So P power 6 is equal to I simply means that you can, ST is also a non-singular matrix. So you can go for, I want ST square is equal to this, right? So ST square is same as, so you can multiply with ST power 6 as many times as possible. So ST power 6 into ST square, which is ST power 8, which is equal to ST power 12 into ST square, which is ST power 14. So ST square is equal to ST whole power 2 plus 6n. So that's the condition. So if you can add power 6 to the ST square. So ST square is equal to ST power any number plus 6n. So m is a integral multiple of 8 is not correct, because ST square is equal to ST power 8. The first number is 8, but the next numbers are not integral powers of 8. So I think B and D should be the answers to this question. So hope you have understood this. So next, quickly go to the next question. So let n denote the set of all positive integers, and consider the sets 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5, 6, 7. S be the set of all functions from A to B such that f of 2 is not equal to 2 and f of 4 is not equal to 4. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So 1 cannot, 2 cannot go to 2 and 4 cannot go to 4. These are the two conditions that are given. So all the functions where these two conditions are not valid go into S. Next, T is the set of functions which belongs to S such that there exists a function g from B to n such that g of f of x is equal to 2 power x for all x belongs to A. For all x belongs to A. So there is some extra condition. The number of elements in T is being asked. What is the extra condition? So T contains all the functions f which belongs to S such that there exists a function g from B to n such that g of f of x is equal to 2 power x. That means g of f of 1 has to be equal to 2 power 1, g of f of 2 is equal to 2 square, g of f of 3 has to be equal to 2 cube, g of f of 4 is equal to 2 power 4, g of f of 5 has to be equal to 2 power 5. So there should be a function, because from B, if you take another function from B to the set of natural numbers, you can have many functions. But what is the condition that this function has to satisfy? G of f of 1 has to be 2, f of 2 has to be this. So only thing that you can observe in this question is that, so f of 1, f of 2, f of 3, f of 4, f of 5 cannot be equal to each other. All of them have to be distinct. As long as f of 1, f of 2, f of 3, f of 4, f of 5 are distinct, you can take them to different numbers, right? Because if f of 1 is equal to f of 2, so g of same number cannot be 2 power 1 as well as 2 power 2. So the condition simply means that 1, 2, 3, 4, 5, f of 1, f of 2, f of 3, f of 4, f of 5 should be different. They cannot be same. So that means it's a 1, 1 function. So among all the functions which satisfy f of 2 not equal to and f of 4 not equal to 4, the 1, 1 functions go into the set T. So how many elements are there in T? That's the question. So how many 1, 1 functions are there where f of 2 is not equal to f of 4 is not equal to 4? We can use inclusion exclusion principle. The total number of functions, total number of 1, 1 functions is one can have 7 into 6 into 5 into 4 into 3. So the total number of 1, 1 functions minus of, so the number of functions where 2 goes to 2. If 2 goes to 2, 1 will have 6 options, 6 into 5 into 4 into 3, minus 4 going to 4, again 6 into 5 into 4 into 3, number of 1 functions, plus the number of functions where both conditions are valid. 2 is going to 2, 4 is going to 4. So, 1 will have 5 options, 5 into 4 into 3. So, this is the total number of 1 functions minus the number of functions where 2 goes to 2 minus the number of functions where 4 goes to 4 plus number of functions where 2 goes to 2 and 4 goes to 4. So, this is called inclusion exclusion principle. So, if you do this, you are going to get an answer of 1860. So, I hope this is understood. The only thing that we need to understand in this is this condition simply means that f of 1, f of 2, f of 3, f of 4, f of 5 have to be distinct numbers. They cannot be same. So, if you go to the next question, a bookshelf contains 6 distinct mathematics and 5 distinct books of physics. So, 6 maths books, 5 physics books. So, from these 11 books, 6 books are chosen at random. X is the absolute value of the difference between the number of maths books and physics books. So, maths, physics. So, 6 books are taken. So, the combinations are 6 0, 5 1, 4 2, 3 3, 2 4, 1 5, 0 6. So, when you take 6 books, this is the number of combinations, all 6 maths, 0 physics, 5 maths, 1 physics, so on. And what is the random variable that is being defined? The random variable is the absolute difference between the number of maths books and number of physics books. So, the random variable value will be 6, 4, 2, 0, 2, 4, 6. These are the possible values of the random variable. Now, they are asking you the mean of this random variable. If alpha is the mean of the random variable, what is the value of 77 alpha? So, you just have to find P of xi. So, mean is nothing but sigma of xi into P of xi. So, now the denominators, what are the denominators? Out of 11 books, you are choosing 6 books. So, the denominator is 11C6, right? The denominator is 11C6. Now, what is the numerator? I will just write the numerators. So, I want all 6 maths books. So, 6C6 into 5C0, 6C5 into 5C1, 6C4 into 5C2, 6C3 into 5C3 ways, 6C2 into 5C4, 6C1 into 5C5. So, you cannot take 6 physics books out of 5 physics books. So, there are 0 options, right. So, the number of options are 66 into, there is only one option like this. So, 6 into 5, 30. Now, once you have P of xi and xi, you need to multiply this into this. So, that is sigma xi into P of xi is the mean. So, really, as you can see, I do not need this, because when you multiply this with 0, you are going to get 0. So, 6C4 into 5C2. So, 6C2 is 6 into 5 by 15 into 10, 150. So, 6C2 into 5C4, 5C4 is 5, 15 5 is 75, right. 6C1 into 5, 6. So, you are multiplying this 1 into 6. So, the numerator will be 6 plus 120 plus 300 plus 75 into 2 is 150 plus 6 4 is 24. So, divided by 11C6. So, what is the numerator? 450, 550, 570, 580, 590 and 600. 600 divided by 11 into 10 into 9 into 8 into 7 by 11C6 is same as 11C5. So, 5 into 4 into 3 into 2. So, this is the mean, and you are asked to multiply it with 77. So, 77 means 11 and 7 are going to get cancelled. So, 10 gets cancelled, 4 2s are 8 gets cancelled, 3 3s are 3 20s are. So, 20 into 5 is equal to 100. So 77 alpha is turning out to be 100. So I hope you have understood this question. So the concept is mean formula. Mean is nothing but sigma xi into p of xi. So we have found the different possible values of the random variable. We have found the corresponding probabilities. We have done xi into p of xi. So next we are going to the statistics question. So consider the data consisting of 10 observations, mean is 5 and variance is 7. Mean of the first 8 observations and variance of the first 5 observations is given. X9 less than X10, the value of 3X9 plus 2X10. Very straightforward question. So sigma xi by 10 is equal to 5, sigma xi square by 10 minus x bar square is equal to variance. So sigma xi, sum of all 10 observations is 50, sigma xi square is equal to 32 into 10, 320. That means x1 square plus x2 square plus so on up to x10 square is 320. These are the first set of observations. Second, the first 8 observations, sigma xi by 8 is equal to 4. So sigma xi is equal to 32 up to 8 observations. So if you subtract this from this, you'll get x9 plus x10. The remaining observations is equal to 18, right? Next, sigma xi square 1 to 8 by 8 minus x bar square is how much? Minus 16 is equal to 3.5 variance. So sigma xi square is equal to 19.5 into 8, right? So 19.5 into 8, which is 0, 4, 30, 32, 72, 76, 7. So 156. So the sum of all 8 observations, squares of 8 observations is 156. So from here, total sigma xi square is 320. The sum of only the first squares of first 8 observations is 156. So if you subtract 1 from this, you'll get x9 square plus x10 square is equal to 320 minus 156, which is 164. So clearly from these two, you can see that x9 and x10, the smaller has to be 8, the bigger has to be 10, right? 8 and 10. So 3x9, which is 24, plus 2x10, which is 20, is equal to 44 is the answer to this. So very straightforward statistics based question. So next, let's go to the 13th question. So consider the ellipse and let hyperbola whose eccentricity is the reciprocal of the eccentricity of E and whose foci are same, they are confocal. P and Q are the point of intersections of hyperbola and parabola root 5y is equal to x square in the first quadrant. So D is the distance between P and Q, D is the distance between P and Q. A and B are integers such that D square is equal to A plus B root 5. What is A minus B? So first let us go for the hyperbola. So x square by 18 plus y square by 12 is equal to 1. So what is the eccentricity? E square is equal to 1 minus b square by a square, which is equal to 6 by 18, which is equal to 1 by 3. So eccentricity of hyperbola whole square is equal to 3 because it's a reciprocal. This is the first condition. And the second condition is that the ellipse and hyperbola are confocal. Okay. So what is the condition for confocality? So 18 minus 12 is equal to, so if the hyperbola is x square by a square minus y square by b square is equal to 1. So the difference between the numbers, the denominators of ellipse has to be same as the sum of the numbers of hyperbola. So a square plus b square is equal to 6. So eccentricity of hyperbola is 1 plus b square by a square is equal to 3. So a square plus b square by a square is equal to 3, which implies a square is equal to 6 by 3, which is equal to 2. So a square is 2 and b square is 4, because a square plus b square is equal to 6. So what is the hyperbola? X square by 2 minus y square by 4 is equal to 1. So now you have this hyperbola something like this. Now you have the parabola root y is equal to, so y is something times x square. So mostly the parabola will be like this. So these are the 2 points of intersection that they are talking about. So you can find the points of intersections, not a big deal. So x square is equal to root 5y. So you just have to put root 5y here. So root 5y by 2 minus y square by 4 is equal to 1. So you're going to get y1 and y2. So if you multiply this with 4, 2 root 5y minus y square is equal to 4. Y square minus 2 root 5 times y plus 4 is equal to 0. So y is equal to 2 root 5 minus b plus or minus root of b square minus 4ac by 2a, which is equal to 2 root 5 plus or minus 2 by 2. So root 5 plus or minus 1. So the y coordinate of this point is root 5 plus 1 and the y coordinate of this point is root 5 minus 1. And you can find the corresponding x coordinate and find the distance square, and if you equate it to a plus b root 5, you're going to get the values of a and b, and you can do the calculations, and a minus b will turn out to be 18. So that's the answer to this question. So next let's go to the 14th question. So it's a question of continuity, right? Continuity and differentiability. So you are given two functions, f of x and g of x. So you are asked to find, so how many points of discontinuity are there for a and b, and a is the points of discontinuity of the first function, b is the number of points of discontinuity of the second function, the points of discontinuity of the second function, and you want a intersection b also. So the first function, if you take f of x is equal to integer part of x cube into ln of 1 plus sine square of pi times fractional part of x. So we are going to look from minus 3 to plus 3, right? So from minus 3 to plus 3, if you take this x cube goes from minus 27 to plus 27, and sine pi times fractional part of x will have integer points, which is minus 2, minus 1, 0, 1, 2. These are the points of critical points. These are the critical points, the points where we need to check for continuity. So if you take this function, if you take the second function, it's like if you take minus 2, so minus 2 plus and minus 2 minus. So depending on where the x goes, fractional part of x will be either 0 or 1, right? Depending on which integer x goes. So whether x goes 2 plus or 2 minus, fractional part goes to either 0 or 1. Whether fractional part goes to 0 or 1, sine pi of 0, sine pi of 1, both of them are going to 0. So you can see that there are no continuity problems to the second function in this. So there are only continuity problems for the first function. So how many continuity problems are there? From minus 27 to plus 27. So not including minus 27 and plus 27. So it's like minus 26 to plus 26. These are the values of x cube where that discontinuity comes. So how many points of discontinuity are there? 26 plus 26 plus 1. So, you have 53 points of discontinuity for the first part of the f of x, and second part is always continuous. So, now you are multiplying a discontinuous function with a continuous function. Sorry. So, you are multiplying a discontinuous function with a continuous function. So, what is the theory? So, when the continuous function becomes 0, when the continuous function goes to 0, it will manage the discontinuity of the function which is beside it. Okay, because this is finite type of discontinuity. So, you can see that at -2, -1, 0, 1, 2, at these 5 points, the value of the second function is 0. So, among these 53 points, so these 5 points are going to be the points where the discontinuity is managed and the effective function becomes continuous. So, 48 points of discontinuity for the first function. Next, if you go to the second function, so what are the points where this is like x cube into sine square of pi times ln 1 plus fractional part of x. So, x cube is always continuous. X cube is always continuous. So, here if you take at the values where x is integer, that is -2, -1, 0, 1, 2. So, if x goes to -2 plus or -2 minus, this fractional part is either going to 0 or 1. So, if it goes to 0, it will be ln 1, which is 0, but if it goes to 1, ln 2. So, sine square of pi ln 2. So, the right limit and left limit are becoming different. So, at all these points you will have discontinuity for this function, but among all these points, when x is equal to 0, the first function is becoming 0. So, it will manage the discontinuity. So, there are 4 points of discontinuity for the second function. So, number of discontinuous for A is 48 plus 2 times 4 minus A intersection B. There are, if you can see, there are no points of common discontinuities, because when x becomes these points, we have observed that there is no discontinuity because this particular function is managing the discontinuity. Okay. So, minus 0. So, 48 plus 8, which is equal to 56. So, the number of the value of n of A plus 2 times n of B minus n of A intersection B is equal to 56 is the answer. So, this is about the multi-correct the numerical type section 3 of this paper. So, next we are going to question stem type. So, there are 2 questions that are given. So, in this C1 is e power minus x and C2 is e power minus x times sin x plus cos x. You are looking at n is the different number of points of intersection of C1 and C2. Alpha 1, alpha 2, so on up to alpha n belongs to 0 to 10 pi. The x coordinates of the points of intersection are alpha 1, alpha 2, so on up to alpha n. So, what is n? How many points of intersection are there? So, e power minus x is equal to e power minus x into sin x plus cos x, right? So, for point of intersection, sin x plus cos x is equal to 1. So, we know the graph of sin x plus cos x. It's like this, right? 1. So, it varies between 1 and root 2. So, if you take 0, it will be 1. Next, at pi by 2, it is again 1. At pi by 4, it becomes root 2. At pi by 2, it again becomes 1. And in the next cycle, so 0, at 0 it is 1, at pi by 2 it is 1. So, within every cycle you will get 2 points where the value of sin x plus cos x is equal to 1. Otherwise, we can also go for general solution. Sin x plus cos x by root 2 is equal to 1 by root 2. Sin of x plus pi by 4 is equal to sin of pi by 4. So, x plus pi by 4 is equal to n pi plus minus 1 whole power n times pi by 4. So, which implies x is equal to, so if n is odd, so 2n plus 1 times pi If n is odd, minus pi by 4 is minus pi by 2, or if n is even, 2n pi plus pi by 4 and plus pi by 4 are going to get cancelled. So x is equal to either 2n pi or this kind of 2n pi or 2n pi plus pi minus pi by 2 is plus pi by 2. So either 2n pi or 2n pi plus pi by 2. So 0 pi by 2. N is equal to 1, 2 pi plus pi by 2. So on 8 pi plus pi by 2 up to 10 pi. Because it's a closed interval 0 to pi, 0 to 10 pi. So you have to include 0 as well as 10 pi. So there are 5 groups of 2 solutions, which gives us 10 solutions, and one extra solution 10 pi. So n is equal to 11. So there are 11 solutions for this. Next, they are asking you what is the value, what is the area of the region bounded by C1 and C2 between alpha 1 and alpha 4. So what is alpha 1? Alpha 1 is 0, right? Alpha 4 is 0, pi by 2, 2 pi, and 2 pi plus pi by 2, which is 5 pi by 2. So you want to find the area between the curves between 0 and 5 pi by 2. So if you take the graph of y is equal to e power minus x into sin x plus cos x and e power minus x. So e power minus x will be something like this. So sin x plus cos x, the curves are meeting at 0. That is, this is one meeting point at pi by 2, at 2 pi, 5 pi by 2, right? So the graph e power minus x into sin x will be something like this. Something like this. So between 0 and pi by 2, this graph is higher. Between pi by 2 and 2 pi, the second graph is the e power minus x graph is higher, and between 2 pi and 5 pi by 2, the first graph is higher. So the area is nothing but integration 0 to pi by 2 e power minus x into sin x plus cos x minus e power minus x, that is sin x plus cos x minus e power minus x dx, plus pi by 2 to 2 pi e power minus x minus of e power minus x into sin x plus cos x, plus integration 2 pi to 5 pi by 2, again e power minus x into sin x plus cos x minus e power minus x. So here the tricky thing is you have to try to get this e power minus x into sin x plus cos x integration. You write that properly. So integration of e power minus x into sin x plus cos x by observation is nothing but minus e power minus x into cos x. Can you observe this? So if you differentiate this, you'll get e power minus x into minus sin x plus cos x into minus e power minus x. So minus and minus will get cancelled. So you get e power minus x into sin x plus cos x. So this is a formula that you usually remember. E power minus x into sin x plus cos x is minus e power minus x into cos x. So if you apply this formula, it will be quite easy. So e power minus x into cos x. So going from 0 to pi by 2, again plus minus e power minus x cos x. So minus of minus will go into become plus. So pi by 2 to 2 pi, again minus e power minus x into cos x, going from 0 to pi by 2, 2 pi to 5 pi by 2. This is one part, and the other part is the integrations of e power minus x. So if you take all this and do it properly, so your answer will look like the options, the form that is given in the question. So you have to compare and get the answers of the value of this, right? So if you do everything, you are going to get the value of this is 2.5. So I want you to do the calculations for this. And finally, we are going to the last paragraph type question. So you are given two ellipses. One ellipse is horizontal, x square by 1 plus y square by 1 by 4. The first ellipse is horizontal. The second ellipse is x square by 1 by 4 plus y square. So the second ellipse is like this. So there are two ellipses. So P be the point in the first quadrant where given ellipses intersect each other. So theta is the acute angle between the tangents to the given ellipse at P. So you just have to find the point of intersection and then go for the differentiations, and you use tan theta equal to m2 minus m1 by 1 plus m1 m2. So to find the point of intersection, x square plus 4y square is equal to 1, 4x square plus y square is equal to 1. You are going to multiply this with 4, subtract it, 16 minus 1, 15, y square is equal to 3. So y square is equal to 1 by 5. You get y is equal to 1 by root 5. So 1 by root 5, and if you calculate x, x will also turn out to be 1 by root 5. So at this point you have to find the differentiations of both of them. So for this dy by dx is equal to minus dou phi by dou x by dou phi by dou y is equal to minus x by 4y. So because x is equal to y, you are getting minus 1 by 4 as the slope of the tangent. And for this, it is dy by dx is equal to minus of 8x by 2y, so which is equal to minus 4. So one slope is minus 1 by 4, other slope is minus 4. So tan theta is equal to m2 minus m1 minus 1 by 4 plus 4, m2 minus m1 by 1 plus m1 m2. So minus 1 plus 16, 15 by 4 into 2 is 8. So tan theta is equal to 15 by 8. So 4 tan theta is equal to 15 by 2, which is equal to 7.5. So this is a very straightforward type of question. And the second question that is asked in the same part, the second question is that alpha is the common region that lies between the given ellipses. What is cot alpha? So you're asked to find the region, common region. Okay, this is the common region that you're talking about. So because of symmetry, what you can do is you can find one of this area. I'll find this area and I'll multiply this with 8, right? We can multiply this with 8. So this region is quite easy. So integration 0 to 1 by root 5, 0 to 1 by root 5. What is this? Is the horizontal ellipse. Okay, so y square is equal to 1 minus x square square root 4y square is equal to this. So 2y is equal to root of 1 minus x square. Y is equal to 1 by 2 into root of 1 minus x square. So 1 by 2 root of 1 minus x square. Okay, so this is this total area. You have to subtract the triangle area from this. So minus the triangle area is half into 1 by root 5 into 1 by root 5. So area of area under the horizontal ellipse minus triangle. This whole thing has to be multiplied with 8. So I hope you know the formulas for this and this 4 times. So 4 times x by 2 root of 1 minus x square minus a square by 2 sine inverse x going from 0 to 1 by root 5 minus 1 by 5. So if you put 1 by root 5, so you get 4 times. So 1 by 2 root 5 into 1 minus 1 by 5, 4 by 5, 2 by root 5 minus 1 by 2 sine inverse 1 by root 5 minus 1 by 5. So this 2, 1 by 5 and 1 by 5 are getting cancelled. So you're getting the area mod of this is equal to 2 sine inverse 1 by root 5. So you want 4 tan theta. Tan theta is equal to 2 sine inverse 1 by root 5. Sorry, you're being asked to find what is the question? So you're asked to find cot alpha. So what is the area? Alpha is equal to 2 sine inverse 1 by root 5. So alpha is equal to 2 sine inverse 1 by root 5. So 1 root 5. So that is 2 tan inverse 1 by 2. So tan inverse of 2 into 1 by 2 by 1 minus 1 by 4. So tan inverse of 4 by 3, which is equal to cot inverse of 3 by 4, which implies cot alpha is equal to 0.75. So if alpha is the common area that lies in between, so cot alpha is turning out to be 0.75. So that's the answer to this question. So that completes our paper 2 solutions. So hope you have understood all the questions properly. Thank you.